Okay, good morning. Today we will be learning on the final part of the chapter 16, which is application of integration in kinematics. Okay, so I believe Miss Catherine has covered video 16.1. So I will try to make this video as short as possible to go through what is the application of learning kinematic in integration. Okay, so just a little recap. Okay, back then you learn on let me see. You learn differentiations in kinematic. So actually we have learned differentiation and integration both together last time, that when you differentiate you're going down one level, when you integrate you're going one level higher. Okay, so how does this take application into? Okay, so there's a detailed explanation here. Give me some time, let me try to zoom in. Okay, so I managed to zoom in. So if you see in your textbook they already mentioned. Okay, so but let's say they give you the equation for displacement. Okay, I repeat again, let's say they give you the equation for displacement. When you differentiate you will get velocity, then from velocity we differentiate we'll get acceleration. Okay, so the same thing, integration is the reverse of differentiation, right? So when we integrate acceleration we'll get velocity, when we integrate velocity we'll get displacement, vice versa, like that. Okay, so this is how the application comes into place. Okay, this is just one of the application that you are seeing for differentiation and integration. There are more. Okay, when if you, like I said in the last video, if you go to maybe some engineering course or anything that related to maths, okay, you will see more application involving between this integration and differentiation. Okay, for this point of time you will only learn this basic. Okay, so usually how I call this is SVA, so that easy for me to remember, just like your physics triangle. So SVA, as we go down, because we going down means, remember, differentiation is you are going down by one level, like I taught in the last integration video. Integrate means we are going one level higher. Okay, we have learned in the last example that when we go one level higher we can find the area. Today we're going to learn another application. Like I said, when you go one level higher you have the few options that you can find. Like I said, SVA, so as you go down you differentiate, as you go up you integrate. Okay, this is how basically kinematics works. There's few theories here how they come up with that also. I'm not interested to cover that because that's not important. So I will do with you work example 5, work example 6, work example 7. Okay, then there will be few exercise here. We will extract and put in the worksheet for you to try out. Okay, and all together I will attach together the work, the answer also, how to solve these problems. Okay, so let me just start with this example first. I'm not sure whether am I supposed to do or just go through. Okay, I think the best is do lah, because we can see things better. Okay, wait, I want to do some adjustment here first. Okay, let's zoom out. Okay, I need to zoom out first. Okay, zoom out. Okay, good. So if you notice, this example say a particle moving a straight line. Okay, like I always taught you guys. Okay, they'll give you too many information, we just take what we needed. Okay, so they said given a equals to 2t plus 1. Okay, before I write the 2t plus 1 I want to write my SVA here. So SVA, as I differentiate I will get down. If I want to go up I need to integrate, I need to go up I need to integrate. Okay, so I need to select few marker first. Otherwise it won't be colorful and you might be lost along the way. That's life, isn't it? Yeah, fine, I don't know what I'm talking. Okay, never mind. So moving forward. Okay, wait, what? Okay, yeah, sorry, I just noticed the video was a bit blurry. Okay, so now this equation. Okay, so I write here work, okay, example 5. Okay, so in work example 5 they give you, okay, for part A they give you a equals to 2t plus 1, and then they ask you find the velocity when t equals to 3. You can see, right? Okay, let me try to focus. Okay, so yeah, so they ask find the velocity when t equals to 3. So like I said, if you write this, easy for you to see. So this is acceleration. From acceleration I want to go velocity, I need to integrate. So indirectly you need to write here v and you integrate this. Okay, so I'm going to write here v integrate, so I get 2t square over 2 plus t, and then do I need to plus c or not? Yes, of course I need to plus c. Okay, so now I got my velocity equation already, which is t square plus t plus c. Okay, so in integration you have learned that you need to find the what we call that, the c value. So how do we find the c value? There's few information I believe is given in the question itself. You see, a particle is moving a straight line in a fixed point with velocity 8 meter per second. Okay, so its acceleration blah blah blah. Okay, this is the important keyword. This one is something to do with your physics. Okay, they say it moving with a fixed point velocity 8 meter per second. So at 8 meter, that means when the velocity, when the starting of the point, starting the point of velocity is 8 meter per second, that means you can declare that time is t is 0, and with that you can find your velocity as well. Okay, so what we're going to do now, okay, we're just going to sub inside and see what we get. Okay, so I repeat that, v equals to 8 and time should equal to 0. I think this part will be covered by Miss Catherine. Okay, there's few theory you need to know. Okay, and also from your physics actually. Okay, because they say a particle is moving a straight line with a fixed point 0 with velocity fixed point 0, that means it starts from some origin with velocity 8 meter per second. Okay, so that means at the starting, that means when the starting of the journey, t has to be 0. Okay, okay, so starting, oh my god, wait, okay, so starting, okay, starting, your t has to be 0, so your velocity will be of course 8 lah, because there's a distance we're talking about. Velocity formula is what? Displacement over time taken. So for that particular displacement with the time 0, your v is 8. So we're going to replace inside here to get the c. So when v 8, t is 0 square plus 0 plus c, so you get your c as 8. Okay, now that you got your c as 8, okay, we got our equation already. V equals to t square plus t and then plus 8. So now that we got this ready, we can find the answer they're asking us. They say find the velocity when time equals to 3. So you just replace inside lah. 3 square plus 3 plus 8. So here you got 9, 9 plus 3, which is 12, 12 plus 8 is 20. Okay, so 20 meter per second. That's your answer for A. Okay, so moving forward, they say find the displacement from O to find the displacement from O when t equals to 3. So they say when the time equals to 3 seconds, they ask you to find the displacement. So like I said, A is acceleration, B is velocity, S is displacement. So indirectly you can know already. Question B is asking you to find displacement. Displacement means we're talking about S. So that means you have to take the V equation, integrate one level higher. Okay, so I know we have space here, so I'll just do it in the next page. Okay, I'll attach this notes also, because you know you have both, so it's totally your choice. Okay, so let me just write the equation here. V equals to t square plus t plus 8. Okay, so we want to find S, that means we need to integrate this equation. So t square plus t plus 8. So when we integrate, we get t cubed over 3, right, plus t square over 2 plus 8t plus c again. Okay, this c will always come and hunt us lah. Okay, so that and then this is the most interesting part to find. You know, okay, there are some things you have to declare in doing this equation. Okay, if you don't declare, you won't know. So one of the declaration that I made earlier, you notice when time equals to 0, you see here, when time equals to 0, because starting point my velocity is 8. Okay, that is something we can get straightforward. And then now we're going to make here, this is displacement. Displacement also we can analogy with distance. That means when my time 0, that means I didn't move anywhere. You agree with me? That means at my time initially 0, my S should be 0, because there's no way at 0 you already move somewhere. Okay, because the journey haven't even started. Okay, so when t is 0, S is 0. So we can substitute inside just because we want to find the what we call that, the c there. So 0 cube over 0 plus 0 square over 2 plus 8 0 plus c. That means our c is 0 lah. Okay, so now we got our proper equation and we can just proceed with substitution. I'm just going to write again one more time so that you know how actually I eliminate the c. So my c is disappeared because c is 0. So now they say find the displacement when t equals to 3. So I'm going to put inside here 3. Okay, so 3 cube, which is 27, plus 3 square, which is 9, plus 8t. 3. Okay, so all you have to do this point of time is press in your calculator. Okay, I don't know where's my calculator. Okay, it's somewhere here, but never mind, I'll just steal the answer from the textbook. Okay, so if you can see the steps is correct, everything is right. Okay, yeah, I need to zoom out a bit from the textbook so you can see down there. Okay, so you can see 1 over 3, 3 cube. Okay, and then 1 over 3, and then you have the A3. Okay, so all will give you 37.5. Okay, so 37.5 meter. Okay, remember this is displacement. Displacement means what, guys? In your physics you have studied. Okay, starting point to the end point. Okay, doesn't matter. So that's how you do this question lah. Okay, so this video itself will really take 10 minutes. I don't want to put one long video for you, so I'm gonna stop this video, and then the next book example I will do in the next video. Okay, please go back to the Zoom to get for the link. Thank you.